So continuing on with our Java discussions, as I mentioned at the end of the last video, so unlike human languages, computer languages are actually very precise and you have to stick to the syntax of the language exactly. But even human languages need correct punctuation though. Being intelligent, we can often work out what's really meant if the punctuation isn't quite right, but punctuation is still actually important. Let's just have a look at this slide. So here's exactly the same text but punctuated in two different ways. So if you find yourself getting frustrated, remember that it's only a computer. It can't think for itself, and you have to actually compensate for that by being very precise in how you write your code so that your poor computer can actually understand you. Okay, so Android Studio is telling us what's wrong there. So we're going to come over here. You can see that it's saying it needs a semicolon. So I'm just going to add the semicolon at the end of that line. And you see that the red little squiggle disappeared and also the red dash, the right hand side of the screen, also disappeared. Now that I've actually run the program for the first time by right clicking, I can actually run it in any future times by clicking on this little green arrow up in the toolbar. Now that doesn't always work until you've either right clicked and chosen the method you want to run or used the run menu. Now you can see that there's already different options for running and we've only got one class. So if you end up running the wrong program later in the course, either right click on the code that you want to run or use the menu. Again, we can come up to the run menu and we can click on run hello world and do it that way. So a good habit I personally get used to is looking at the code that I want to run and just right clicking it and running it that way. And then I'm always sure that I'm running the right project. So now that we've actually got a method containing two lines to execute, and unless we do something to tell it otherwise, Java will just start at the top and obey the instructions on each line until it gets to the end. So we'll have to look at what we can do to make it behave differently in a minute. But before that though, we need to look at variables or fields. Now you'll see both terms used and they are pretty much the same thing. The difference is in where they're defined. Now variables exist inside a method only and can't be accessed from code outside the method, whereas fields are just variables that can be used from anywhere in the class. Now that will make more sense soon. For now we're working with a single method, so I'm going to stick to that when I'm talking about variables. So a variable is just a name that we give to an area of memory so that we can refer to the contents by name. It's a bit like the mailboxes in an apartment block. There's a bank of mailboxes in the lobby and each one is labelled with the name of its owner. When the post person delivers the letters, they put mine in a mailbox labelled Tim. So that makes it easier for me to get my mail. I just open my mailbox rather than having to check them all. Now once again, there's a difference in the way humans and computers behave. The post person wouldn't try to force a parcel into my mailbox because the mailbox slot's only big enough to take letters and things wouldn't go well if they tried squeezing a large parcel in. But computers don't think like that. So we have to tell them what kind of thing we can store in each and every variable that we use. So let's see how that works shortly, but let's just run this program just to make sure that it does work and show the second line of output. So I'm going to right click in there, click on run hello world.main. And down the bottom you can see my first Java program is now below the hello world. So clearly Java went through and showed the first line executing line 9, and you can see the line numbers over here to the left, then it did line 10 and continued on. Alright, so let's work on this example of a variable now. So I'm going to come down here at the end of the system.out.println on line 10. I'm going to press enter and then enter again. Enter or return. So anytime I'm talking about enter, if you've got a return key on your keyboard, use that key. And I'm going to type string space Tim equals, then in double quotes, Tim Bachauka. And then I'm going to do the SOUT for the shortcut. Press enter or tab at that point, and I'm going to type Tim. So what we've done here is we've created a variable called Tim, and we've put the text Tim Bachauka in an area of memory that's now labelled Tim. So we've told the computer that this area of memory can hold string values, so it's fine to store text there. Then on the next line, we print Tim. But instead of printing the three characters T, I and M, the computer will go off to the area of memory that we've labelled Tim and get the contents of what's in there at that area of memory. It then will print out those contents, not the name that we've given to that bit of memory. So on line 12, we've declared the variable Tim. Now when we declare a variable, we tell the computer what type of information it can store. So in this case, it can store string objects. And we then gave it a name, in this case Tim. Again, I'm still looking at line 12. Now when I run the program now, let's just confirm that it does what we think it will do. It should print out my full name. And you can see now as the third line of output here in the run window down the bottom of the screen, it's showing my name, printing out my name, Tim Bachowka. Now often, you'll also give the variable a value at the same time, which we've done here by using the equal sign, in line 12 here, then the string that we want to assign to the variable in double quotes. Now you can assign the value later if you want. So we could do something like this instead. That really just does the same thing. So we've defined the variable Tim on line 12 and we've said that we're using a type string. Then on line 13, we assigned the value for the variable Tim. The important thing though is that the variable Tim must be declared before we can assign a value to it. Until we declare the variable, the computer doesn't actually know what kind of information it can store, and so it hasn't allocated any memory for it. It's a bit like the postie trying to deliver a letter, but there's no mailbox with my name on it. Being human, they can still make decisions for themselves, and perhaps they might ask my neighbours if anyone called Tim has moved in recently. The computer, however, won't make any decisions that you haven't programmed it to make, so you'll just get an error. So let's see that. If I actually delete this declaration on line 12, I'm going to turn it into a comment instead. And I'll explain that in a minute, but basically I'm putting 2 slashes there. And notice how first the colour changed to sort of a greyed out colour, but secondly we've now got something showing in red, the Tim variable name on line 13 and 14. So we've actually got 2 errors, and you can see we've got over here the 2 red dashes in the margin. Cannot resolve symbol Tim. They say the same thing, and if we hover over the red error as well, you can see that it's saying the same thing. So that's a good habit to get into if you see something in red, is just to move your mouse and hover over it, or hover over to the right hand side to see if you can figure out what's going on. So basically it's showing they're both showing the same error, cannot resolve symbol Tim. So that's computer speak for I've got no idea what you mean by Tim. And I won't actually be able to run the program now, but I'll try anyway. So I'm going to right click and run it again, or at least attempt to run it. We actually get an error at this point. Now the error doesn't actually make a lot of sense, and that's because Android Studio is really intended for creating and running Android apps. Now we're going to be looking at the error messages later on. For now though, there's no point trying to run a program if Android Studio is highlighting errors on the screen, and of course it is doing that here right now. So what's happened here is that we haven't declared the variable Tim, so Java's really got no idea what Tim is and what we're referring to. Now instead of deleting the declaration on line 12, I turned it into a comment. So any line that starts with 2 forward slashes like this is ignored by Java. So it's a good way to put comments in your code to explain what the code's doing, and it's a good way to temporarily disable lines of code so they aren't executed, and that's what happened in this case. By putting the 2 slashes there, that line wasn't executed and was completely ignored by Java. So I'm going to uncomment that line now. So I'm going to put my cursor on that line, but I'm going to actually uncomment it by using a useful shortcut key. Now on a Mac it's Command and slash, and on a PC running Windows or Linux it's Control slash. So in my case I'm going to hold down Command and press slash, and you can see straight away what happened there was that the 2 slashes were removed. Notice that the colour changed slightly on line 12 with the string declaration, Tim variable declaration, and also most importantly the 2 errors that were showing on line 13 and 14 have disappeared. And I'm just going to come up here to move that back, press delete once so it's all lined up correctly. And just out of interest with that shortcut, if I hold down Command and press slash again, it puts the comment on, and notice how it's gone to the next line automatically, and come back, press it again, and uncomment that. So it's like a toggle, it turns it on or off depending on what the current state of the line is and as to whether it's a comment or not. Alright, so I've declared Tim to be of type string, which means it can only hold text values. So if I try to assign a number to it, that's not going to work. So let's see how to do that. So what I'm going to do is change this now and try and assign a number to it. So I'm going to type 32 in there and put a semicolon after it. And we actually get an error. And if I hover over the error, we get incompatible types, required java.lang.string found int. So we can't assign a number to a string variable. Java doesn't allow that. Now you might be tempted to get around that by enclosing the number 32 in speech marks or double quotes. So I could come up here and put a double quote around those. And that will work. There's no error now, and I should be able to run the program. So if I run that, we can see that we've got the first two messages showing, and then we've actually got the number showing as the third part. But we haven't really fooled the computer though. Tim is still storing a string. It's just made up of two characters, 3 and 2, that happen to be numbers. Now it could be used to represent the number of my mailbox, but not my salary, for example. So in other words, we can't do sums with it. If we want to treat it as a number, then we actually have to declare it as a numeric type. So let's put some extra code in to declare a number. So I type in something like int Tim's salary equals 32. And the next line, int monthly, is equal to Tim's salary times 4, and we'll talk about this shortly. Then I'm going to do a S out, and I'm going to print Tim's salary. And notice when I type Tim, Android Studio is giving us two options, and I can select which one that starts with Tim. I want the Tim's salary. If that's the one I want, I can just press enter. Then on the next line, S out again, and I'm going to print monthly. Just press enter to select the one that I want. Alright, so what have we done here? Well, the most common Java type for storing whole numbers is int, which is short for integer. So by declaring Tim's salary on line 16 to be an int, it's now treated as a number, and we can do arithmetic with it. So I can multiply Tim's salary by 4 to get my monthly salary, and we've done that on line 17. So there's a couple of things to note here. First, we've declared two variables to be of type int, which means they can store whole numbers. The second thing is that we can use the value of a variable in calculations, then assign the result of that calculation to another variable. So we can see that happening on line 17, where the code multiplies the variable Tim's salary by 4, then assigns the result to the variable monthly. So when I actually run this program, let's just see what it does. So you can see we got the first printout of 32, which is because we've assigned the string value of 32 to Tim, and then we printed that out. But in the second case, we've printed out Tim's salary, and Tim's salary was defined as 32, so that's what the second 32 is. But then the calculation for monthly was basically the value of Tim's salary, which was 32, times 4, and that's 128, and by printing out on line 19 monthly, that prints out the sum, which was 128. So again, just remember, although the 32s here, although they look identical on the screen, remember that one's a string and the other's a number. So if I actually try and multiply Tim by 4 on line 17, we'll get an error. So if I change this Tim's salary, double clicking it, and I can just type in Tim. Noting here the type, one's a string and one's an int. So I've actually selected the Tim to be the string now. If I click in there, we'll get an error. And if we just hover over it, it says operator star, being the multiplication, can't be applied to java.lang.string. That's a little bit cryptic, but basically it means that you can't multiply a string by an integer. And actually you can't multiply a string by anything, but the computer doesn't do that kind of semantic reasoning. It sees a string and an int, so that's what it reports. Right, so I'm going to put that back to get rid of the error. So I'll put that back to Tim's salary. And I'm also going to change the Tim value back to my name just to avoid any more confusion with those numbers. And we'll just run it again to make sure that works. And that's good to go. Alright, so I'm going to finish the video here now. In the next video, we'll continue on with our exploration of strings and numbers. So I'll see you in the next video.